Hey everyone, welcome to another Reasons and Resources episode. In this episode, we're going to take a look at Fortran. So, as this episode has progressed, we're now getting into that group of languages that have been around for an awful long time. So things like Fortran, COBOL, Algol, more specifically I think Algol 68, and Lisp. But we'll start off with Fortran for this particular episode. So it's still having stable releases released. Fortran 2023. There's the ISO IEC number if you're interested in such things. Released on November the 17th, that's 15 months ago. So they're still putting out releases. And as always, first of all, I'm just going to explain why did I have a desire to learn Fortran? Why might you want to learn Fortran or not? And all the other usual things that I go through, like there are sort of resources, which are excellent group of resources we have here that I'm going to go through. And I'll include a link to everything in the description, as usual. And I'll talk a little bit about the entry on my own Programming Polyglot WordPress site, which is an ongoing project that I've mentioned before. I'll include a link to that as well. So yeah, been around since 1957, 68 years old. Developed by John Backus and IBM. And I suppose I became interested in Fortran when I read a comparative programming book sometime I think in the 90s, and around the time I read that book I got interested in creating my own sort of programming language library. And of course at that point we're pre modern internet, and well, I still am interested in programming books, as I've mentioned on several occasions, and you've seen my Life in Objects episodes. And I'll have to dig this out when I have. The book I actually have is this. It's still kicking around on Amazon. And Fortran 77. So I looked at the publication date on this and it came out in 1990. Would you explain why they've got an introduction to Fortran 90? So I know I didn't buy it. I don't think I bought it when it came out. It just doesn't make sense. I don't think... What does it make sense timeline-wise? Yeah, I'm trying to remember when I bought the comparative programming book, whether it could have been as early as that. But certainly, there's no way I could have bought it before 1990. And this book was specifically referenced in that comparative programming book. But one of the I think I find so interesting, and this is something you get with really old languages like Fortran, is over successive versions how certain features, if you like, certain support for certain features have come in, and those features being stuff anybody that's learned modern programming languages or more modern programming languages will probably just have worked with these from the get-go. But what I like about Fortran is, you've got Fortran 77, they added character data types, structured programming, array programming, modular programming, generic programming for Fortran 90. So that would have come in around the time that the book I've mentioned was published. Parallel computing in Fortran 95. Object-oriented programming was introduced in the language in 2003, and concurrent programming in 2008, basically. So yeah, interesting to see, how its features have panned out. It's also a good one to track down if you're like me, you're fascinated by the evolution of languages from the early days. You can track down all these nice PDFs of languages from way back when they were first created. So like I said, for me, if you're asking why did I become interested in trying to learn it and taking a look at it, is historical reasons and my fascination with the evolution of programming languages, and it sort of forms the basis of so many, it's influenced so many other languages in its history. Now, in terms of outside of purely, interest or academic study, why else might you want to learn it? Well, as it says here, it's used in scientific and engineering applications, so weather prediction, element analysis, computational fluid dynamics, plasma physics, geophysics, all the really like high intensity science and engineering stuff. And it's very popular in there. It's a high performance computing language, and it's used for programs, as it says here, that benchmark and rank the world's fastest supercomputers. Now, I don't know off the top of my head how. I'm going to talk about some resources online where you can learn Fortran, but I'm not super familiar with where the language now might be specifically taught at undergraduate level. So just putting that out there. So I'm not like a fountain of knowledge on, okay, if you want to learn Fortran, at a academic level or, undergraduate level, this is specifically where you need to go. What I can show you is if you wanted to learn it yourself, this is where you could go. Okay, just so you know. Now, and again, the thing with a lot of this stuff is you can see it's still in, being actively released, which is a good sign, but it's not as widely used as some of the other languages we might be more familiar with. So in terms of thinking about what is the demand for this language, if I learn Fortran, are there any jobs for it, it's really a question of doing that analysis before you decide to commit yourself to learning, if that would be the only reason for learning and you weren't learning it for purely, like me, fun or interest. So just bear that in mind. Saying that, there's an awful lot of legacy code out there that wouldn't still need to be maintained. It does have every use or ease of use within the scientific computing community, and so there are certain things in it which are play to that, certain strengths it has that work really well with those things. Now, of course, I accept that a lot of people now, if you're working in something like, say, data sciences, then of course the go-to language is going to be something like Python, or maybe you might use R, or maybe you might even use like Julia if you'd like to keep up to date on such things. But obviously there is a region within scientific computing where there's certain things you need to do which get done well in Fortran. And also with the language, there's this interesting evolution and backward compatibility to ensure that the features that were supported in the early versions of Fortran are still, supportable today without significant rewrites. And as I've said, at certain points in Fortran's history, they've introduced new features to make it even more powerful. And I'll include links to various important points, if you like, in the language. I'll include a link to Fortran 95 as well, and modern Fortran, as I believe it's called, and also some code examples as well. Now, if you're already familiar with certain types of languages, then when you look at the code, you may recognize certain code structures. Now, one thing to bear in mind over time, as you look at the examples, you'll probably notice a shift from this sort of all uppercase to this style. And even a change like that, it's interesting. Always makes it look quite different. It's interesting to sort of lay out the same in the two different languages. But when I see this, it really does take me back to the days when I first learned BASIC. Because back then, every single language I looked at, everything was like in uppercase, Well, at least all the keywords, and I think the variable names as well. So yeah, it's you probably hear it in my voice. It brings a smile to my face when I sort of see this. That to me, I think, was the big difference when I'd sort of gone from seeing early BASIC stuff like that, snippets of COBOL, snippets of Fortran, because we did talk about them on the when I did computer studies at high school. So I was lucky enough to do it back in it was into the 70s, really, into 1980, I think. So to learn it then, learn like the sort of languages that were around then, and the way they looked aesthetically, I suppose, and the way they laid out on the page, and then you sort of switch to, say, the first time I looked at, I don't know, C, I suppose, and it was more like this had this sort of look to it, roughly. And it's nice in this article, it's particularly useful wiki books actually for the programming language ones, to get an overview of how a language might look over time. So let's now look at more of a industry breakdown. So the Stack Overflow survey. So we're still looking at the 2024 one, because 2025 is not going to won't be out as of this video. I mean, once at a certain point in this year, as I'm doing these, obviously I'll switch to the 2025 one. And you can see, if you look down the list, so this is most popular technologies in answer to this question. We've seen this on previous weeks. I always like to sort of reference against this. It provides a sort of a baseline in some ways to this series. And if we try and find Fortran, we can see the in terms of popularity, and in answer to this question, which programming, scripting and markup languages have you done extensive development work in over the past year, and which do you want to work in over the next year? If you both worked with the language and want to continue to do so, please check both boxes in that row. And so we're running down here in amongst the Zigs, the Julias, the Clojure, Lisps. So it's an interesting mix between older languages like Prolog and some of the newer stuff which might not necessarily be so well known. There's COBOL down there. COBOL, I suppose I should really call it. And I don't think Algo will be anywhere on this list. Could be wrong, but highly unlikely. So if we now look at this, so it's the same answer, but it's just expressed differently. And we go down and sort of look at the difference between those two parts of the question. So this is the desired, which is 0.9%, and this is the admired. Okay, so we're getting pretty low down Again, we've got Prolog down here. We've got COBOL. Prolog came out quite a bit later, I think. Trying to remember the exact date, and I would have covered it in an earlier episode thinking about it, but I can't remember off the top of my head. But I find this is a really useful language to learn because it opened up and made me understand a lot of pattern matching programs a lot easier. Because just the way it was laid out and the way the logic's done in it. And then when we look at the top paying, it's somewhere in the middle here. So obviously you get this situation with languages like this where, not many people relative to other languages might know it or have been taught it. And so there's a sort of high demand for a low number of positions, I suppose. At least that's the impression I get. And you can see again it's sort of grouped together with COBOL. And again we've got other languages. Some of these are languages which sometimes are down here because they're languages where they're used as a teaching language, but may not necessarily necessarily used every day. But some are. But also the other problem is that loads of people know them. So you've got things like Java, HTML, CSS are quite low down top paying technologies because, show me a program, a degree program where at some point it hasn't had, Java, JavaScript, HTML, CSS on it. Now, interestingly, where is it? So JS is just above here, but again, it's in this bottom area. So this is somewhere in the middle. So you're sort of benefiting from maybe there's not so many people knowing it out there. But, relatively speaking to other languages, there's not so many positions. And then you get other jobs where, these sort of languages are in high demand because, again, not many people know them, but there are also some of them, not all of them, are newer languages. I mean, Erlang's been around for quite a while. But it is interesting these top two Beam languages are up here as well. So it's always nice to see, I think, how things relate to one another on this chart. So resource-wise, knock yourself out. I mean, this is another one where the sort of main, if you like, the main resource, I would call it, which is Fortran-lang.org. There is just so much stuff here, and you could probably just do everything in here. So you've got your, introduction, the main page. Then you've got information about learning Fortran, so quick start tutorial. You've got the Fortran language roadmap, okay, which gives you some idea of where everything's going and where it's come from. A nice page about Fortran compilers. This is the one that I downloaded, I think, but there are other ones you can choose from, along with some commercial ones as well. So it starts off with the open source ones, which is invariably what I end up using. That's an LLVM based compiler. But yeah, GNU Fortran is the one that I use. Fortran packages, community page, and I've also got a link to the posts as well for the newsletters. And then this, which is always nice to see on the main site, which is a Fortran playground, so you can play around without even having to download the compiler. And it's got a quick start tutorial in it as well, which is really cool. So you play around with this, see what it does. Run from up here, you get your output. So it's obviously compiling and running there. It's a little bit slow, not quite sure what's going on there. Anyway, I will move on. Yep, the standards, if you're really interested in the standards, there's the page for the standards. Then we have an interesting learning resource here from Princeton. So there's various versions of their modern Fortran course, which you can check out. And there's a number of self-paced online courses as well. That's really useful. In terms of videos, I just sort of always try and share, just because I think they complement them nicely. I mean, there's lots of training, YouTube tuitional stuff you could track down, but what I try and do is sort of flag up the ones where I might be interviewing the creator of it, or there's an interesting talk done at one of the conferences. So I managed to track this down, which is on the Association for Computing Machinery YouTube channel, and it's actually an interview with Dr. John Backus, who at IBM created the language. So that's pretty cool if you're interested in these sort of personal reflections and reflections on his work in industry. He was a 1977 ACM Turing Award recipient. Then there's interesting talk, generic programming in Fortran 22Y. So there. And then this channel, Fortran programming language. Now I have noticed, I think this was the one where there's several different versions of this channel. So it looks like over the years there's been several attempts is the wrong word, but yeah, it seems to be the same group have had at least one other version of this channel. And interestingly, these stopped 8 months ago. So I don't know how much this is kept up. However, there is on the fortranlang.discord.group section, the Hello Fortran Code for Thought podcast. The Code for Thought podcast. There's an episode of that where they specifically were talking about Fortran, and I actually have the main Code for Thought page here. So they talk about other things, but there was a Fortran episode on there as well. Also, Advent of Computing, which I do listen to quite a bit, have a Fortran episode, which also introduces compilers and early programming as well. Puts it on an interesting timeline historically. Fortran is also featured on Exorcism, and you get the usual suspect of things to try out on here. So there's a sort of Hello World tutorial as well. And one of the reasons why I always go on about Exorcism is I like the idea you can sort of jump around with different languages and sort of retry the same challenge but in a different language, if that's your thing. And then finally, this fella. So yeah, on my website, WordPress, I suppose, WordPress blog website, whatever you want to call it. I'm constructing it like a website. Actually, I might do some blogging on here at some point, possibly. But at the moment, I'm mainly sort of constructing this grid here. And you can see quite deep in now, so anything with a underline and a bold is content. that's clickable. So yes, indeed, we have a Fortran entry. And the usual categories are in here, as it was the same categories across the different languages. So binding and scope, functions and closures, frames and argument passing, prototypes and classes, extension. And in different languages you might see that those categories, there's a good deal of overlap. So like things like dispatch, and operators is in here, control flow, all the good stuff, matching, type systems. And some of these are, again, the terminology might have slightly different, contextually be slightly different in different languages as well. Some of the things, I mean, if you're talking about type inference, it's the same across all languages. Immutability is in here, persistent structures, and again the way it manifests itself is going to be different. Like in some languages there may not be necessarily, that might not be implemented in the usual way, but you may be able to do a workaround which does a similar thing or has the same, the same effect, the same result. Processes and threads, this is always interesting to see how the languages implement it in different ways. Messaging. And you can see with some of these I've also included a little bit of information about, if you want to run the code, how that might look like on there as well. Synchronization. So once you get down to this point, this is where you sometimes see quite a bit of differences between different languages. We're talking about pointers and garbage collection here, particularly in the area of metaprogramming. And some of these terms, like when you talk about messaging in a language, it can get a bit foggy in terms of, for that particular language, what does it mean when someone says messaging? So depending on the way in which the language is used, that word may have different meanings. So it's always interesting to see how that might pan out in different languages. So there we have it. Hopefully you enjoyed that. It's always interesting looking at new languages. It always makes me excited when I see or revisit as well stuff that I've not seen for a little while. Thanks once again for watching. Bye for now, and I will catch you in a future